Hello everyone, welcome back to my channel. So let's start with today's lead code question. Today's lead code question is Trionic Array and this easy level. Let's see. We have an array nums and of length n, and an array is trionic if there exist indices such that index 0 to p is strictly increasing, p to q is strictly decreasing, and q to n minus 1 is strictly increasing, and they can't be saved. Indices can't be saved. Written true if the nums is trionic, otherwise false. So let's solve with, okay. So like 1, comma 3, 4, 5, 2, 1, 6, 8. Now see, this is trionic. How? As this is 0, it is increasing till this. So this is P, and it's decreasing till this. This is Q, and this is increasing. Thus this is n minus 1. So this is trionic. We have to justify three condition as 0 to p, strictly increasing, p to q, strictly decreasing, and q to n minus 1 are increasing. And they can't be equal. 0 is less than of p, is less than of q, and is less than of n minus of 1. How will we solve? So let's see. First we have to find that if there is any condition that's with this, if there is any condition that fit this, or there is any condition that fits this. How we will do that? First, first let's take I equals to 0, starting with 0, p equals to 0, q equals to 0, and we have it. Okay, now, now, while loop, we will do while loop I plus 1 is less than of n. So, and nums of I is greater than of. And it is strictly so if we didn't use the equal sign, nums of I plus 1. Nums of I is less than of, if nums of I is less than of nums of I plus 1, strictly increasing, then I plus plus. So this will go through till we get the, till we get start with the decreasing value. So now here we will check if I is equals to 0. If it still remains to 0, means second number is not the increasing value, then we will return false. But if it is not, then p is equals to I, as we have gotten the, as we have gotten this index. Now we have to find this. And for this, again for decreasing, I plus 1 is less than of n, and then nums of I plus 1, this should be uh, is less than of nums of I, means forward value is less than of nums of I, then I plus plus. So this is for decreasing value, as last value is as before value is higher value. Now see, we will again check if I equals to p, means its value didn't increase, as we can't have p and q as same value. then return false. If it is not, then we have got our Q2. Now for increasing again, we will again use this one here, and here we will check if I is equals to Q, means this value did increase again, then return false. Otherwise, I must be is equals to return I must be is equals to and minus 1. If it is true, return true, otherwise false. That's all. Let's show to you guys the code. Here it is the code. We have taken the n value p, q, i. First loop for increasing value, strictly increasing. Second loop for decreasing. Third again increasing. We have checked the condition here. If I is equals to 0, then return false. If it is not, then update the p. Then we compared with p. Otherwise, if it is true, otherwise update q. As we have last value, we have checked it. Now, what is time complexity? Time complexity is O of n. We use the three loops here. Space complexity is O of 1. That's all. That's it. Here's the question. Let's submit it and show it to you again, guys. Submitted. All test cases are passed. That's all. Thank you for today. Please like my video and subscribe my channel.